So today we're going to be talking about Chapter 1, Section 2. And this is our essential question is how can I write a piecewise function? So we've already talked about absolute value functions on Monday and Tuesday. And then you talked about inverses on Wednesday. So we know a function is any relation that has exactly one output for every input. And it has to pass that vertical line test. So that's where if we have a graph, we take a vertical line which is going up and down, and we can only hit one point at a time. So pretty much most of the things that we've been working on with this year have been functions. So a piecewise function is a function defined by two or more equations. So we always have our function f of x or g of x, h of x, whatever you're going to call it, and then we have equals, and then we're going to have these French bracket here. Just do the best you can. I know that they're kind of difficult to make sometimes. And then we'll have a list of equations, and then after our list of equations we always do a comma if, and that's going to tell everybody when they're using that equation. So for example, this graph here uses x minus 2. So this guy here, if x is less than or equal to 0, and it uses 2x plus 1, this equation over here, if x is greater than 0. So for our piecewise functions, we're going to be working on two specific types of piecewise functions because they can get very complicated. And so what we're going to be working on is we are going to be working on our absolute value functions and turning those into piecewise functions. And then we're also going to be working on one other type of function or piecewise function that we'll talk about in a little bit. But first we're going to focus on those absolute value functions. So I want to make sure you have enough time to get all of this written down. Main thing that you need to remember here is if it's an inequality, it has a line. That means that our dot is shaded in. So you can kind of see there that that dot is shaded in. And then if there's no line, then it has to be an open dot. I'm going to be very particular on whether it's an open or a closed dot. So make sure that you get that down correctly. You need to pause right here so that you have enough time to write. You can go ahead and pause. I'm going to continue on, but you can go ahead and pause at this screen right here, and that way you can see all of this and write it down. So we know that absolute value functions are V-shapes. So our goal for number 1 is we are going to write f of x equals 2 absolute value of x plus 1 minus 4 as a piecewise function. Sorry. So again, number 1, write f of x equals 2 absolute value of x plus 1, close your absolute value, minus 4 as a piecewise function. So first thing that I would do is I would decide how is our absolute value going to look if we were to graph this. So we know that since this is a positive 2, we really don't care that it's a 2, we just care that it's a positive right now. If it's a positive, we know it's going to be opening up like this. So if that's the case, then I know I'm going to have something that looks like this for a positive a. So now if I'm looking at this v, as we go from left to right, this is decreasing, which means going down. So that has a negative slope for this specific side. And then it has a positive slope for this specific side. So I would always draw out what your V shape is going to look like. And then write what side is positive and what side is negative. Because that's going to help you when you go to write your piecewise function. And then I also wrote down what my vertex is. So if this is a positive 1 inside, it's always opposite of the inside, same as the outside, so it's a -1, 4. So now that I have this written down, this is going to help me when I go to build my piecewise function, this information. So now we're going to talk about, well, how do we build that piecewise function? So we kind of talked about how absolute values were very similar to our quadratics. So what we're going to do is, since a v is made up of two linear equations, or two linear sides, we're going to split up our equation into two separate ones. So we know that one has to be a negative and one has to be a positive. So what we're going to do is we're going to take our function, we're going to change our absolute values to parentheses, and we're going to write it down twice. So everything stays the same except for the slope changes to a negative on one and a positive on the other. So for this left side, I have negative 2 parentheses x plus 1, close your parentheses, minus 4. For my other one, I have 2 parentheses x plus 1, parentheses, minus 4. Now I want these to be in slope-intercept form, which means I need to simplify this. So I'm going to start simplifying by distributing this. So I have negative 2 times x gives me negative 2x. Negative 2 times 1 is negative 2. And then I have this minus 4 that I'm just bringing down because it has nothing to do with my parentheses right now. Now that I have that, I want to combine my like terms. I can combine this negative 2 and negative 4 and get a negative 6. So my first equation that I came up with is negative 2x minus 6. For the right side, I have negative 2, or I have 2 times x is 2x, 2 times 1 is 2, and then bring my negative 4 down. When I combine my positive 2 and my negative 4, that gives me a negative 2. So to get these two things, we took our original function, we split it into two separate equations, made one a negative and one a positive. That's the only thing that changed, and that's because we have a negative side and a positive side. So now these are the two equations that I'm going to use to plug into my piecewise function. So I'm going to start building my piecewise function. So we have f of x, because that's what our function was called, equals, do the best you can to build these French brackets. If I go back to my original guy, what my V-shaped graph would look like, I have the negative on the left, my positive on the right, so that means my negative needs to be written first. So I have negative 2x minus 6 on top, and then 2x minus 2 on the bottom. Then I have my comma, if. I'm always going to do x, so I have my x's. Now if I'm looking at my original guy, my negative is on the left, so my inequality is pointing to the left, and then on the bottom my inequality is pointing to the right. This negative 1 came from the x value of my vertex. So my vertex was at negative 1, so that's what I put in for my boundary. X is less than negative 1, and x is greater than negative 1, and then I just need to decide, out of these, one of these has to have a line. It doesn't really matter which one you give a line to, but one of them has to have a line. And so I just put it on the top usually. So this little helper is going to help you when it comes to writing it. So if your A is positive, you know you're going to be opening up, and then you're going to have your negative on top, your positive equation on the bottom. If your A is negative, it's going to be opening down, so your positive equation will be on top and your negative equation will be on bottom. So I'm going to go ahead and hold here for a couple minutes so that you can get this stuff down. I would like highlight this or something because it's going to be very helpful for you. Remember, this h is coming from the x value of the vertex. So if you still need a little time, go ahead and pause the video. If everybody has this done, you can go ahead and move on. So I'm going to move on to the next page. So number 2, we're going to do another one where we practice. So here's our problem. Number 2. Write the piecewise function for f of x equals negative 2/3 absolute value of x minus 6, close your absolute value, plus 7. So like I said, first thing you always want to do is you want to do what would your absolute value look like. It's a negative 2/3, which means it's going to be opening down. So this is my positive side. This is my negative. So positive will go on top, negative will go on bottom. And then my vertex is at opposite, so this is going to be at 6, negative, or positive 7. 6, 7. So this is the one that I'm going to use when I go to write my bounds of my piecewise function. So I'm going to go ahead and I'm going to build both my equations. I have my negative 2/3 parentheses x minus 6 plus 7, and positive 2/3 times x minus 6 and then plus 7. So I'm going to distribute. Well, I know that negative 2/3 is the same as multiplying by negative 2 and then dividing by 3. So it doesn't really affect my x. It gives me negative 2/3 x. And then I have negative 2 times negative 6 gives me a positive 12. And 12 divided by 3 gives me 4. So I have 4 plus 7, which gives me 11. For this right side, I'm going to distribute that 2/3, which gives me 2/3 x. 2 times negative 6 is negative 12 divided by 3 gives us negative 4, and negative 4 plus 7 gives us positive 3. So here are two equations. It doesn't matter what side they're on, whether they're on left or right. The only thing that's going to matter is when you put them into your piecewise function, the positive has to be on top, the negative has to be on the bottom. And you could have done the times the negative 2/3 and times the positive 2/3 in your notebook. So I'm going to go ahead and write my functions. We have f of x equals my French brackets. Positive goes on top, so I'm going to do my 2/3 x plus 3 on top. If x is less than, and then I use my x value from my vertex 6. And then negative 2/3 plus 11 if x is more than 6, because this time my positive is on the left and my negative is on the right. Here's our piecewise function. So you should be able to put any absolute value function into a piecewise function. So the second type of piecewise function that we're going to be talking about is our something called a step function. So a step function is a piecewise function defined by constant value over each part of the domain. So that's kind of confusing definition, but it's not that bad. So if this is our function that they give us, we have 2, 3, 4, 5, 6, 7. If, so it's going to be 2 if 0, if it's between 0 and 2. If it's going to be 3 if it's between 2 and 4. 4 is 4 and 6. 5 is between 6 and 8. 6 is between 8 and 10, and 7 is between 10 and 12. So first thing I would notice is that all of these left bounds, the lowest number in the bound, has our line underneath, which means they're the closed circles. Our right side is our open circle. So I went ahead and I made a graph. So I have my x's 1 through 12, because these are my x values that I need. 0 to 12, so I have 0 to 12. My y's are these ones, so I have 1 to 7. So I'm going to go to 2 on my y, and I'm going to put a closed dot, and I'm going to draw a line until I get to 2, because my bound is from 0 to 2. Open circle, then I'm going to go up to